Okay, we have here another integral today. This one was sent to me by Sid. We've got the integral from 1 to infinity of 1 over x times the a root of x plus 1 dx. So to get started with it, one thing I was trying at first was this is a lot like a formula we have when the lower bound's 0. We've got a beta function formula for it that I've used a bunch of times. But there's definitely a couple problems with it. First of all, that's not a 0, and I don't think, I mean, we could manipulate it, but it's still not going to work. The other thing is, even if it was a 0, I don't think it would converge in this case anyway, so we'll skip that idea. So what I want to do instead is actually, let's do a u substitution just for this part. I don't want to include the 1, even though it would go away when we take the derivative, but it will complicate this, I think. So let's just do u equals this thing. And of course we could write this the other way. We could write it as x to the 1 over a, where we have this condition that a is greater than 0. That's important, I think. So then from here, what I can do before I take the derivative, let's solve for x. So I can take it like to the a power on both sides. So let me write it out. So if I have x to the 1 over a, we can raise this to the a power, and we can raise the u to the a power. So what we get is x just equals u to the a. So now we'll go ahead and take a derivative. That's just going to be power rules. So we get dx is going to be a times u, a minus 1 du. And so let's go ahead and substitute it. First, we want to plug in infinity someplace. Here it doesn't matter. We plug in infinity, it's still going to infinity. You plug in 1 to any power, still 1. Dx is going to be all this. Let's take the a out front as a constant. So we just have u to the a minus 1. du, x is going to be this, so we have u to the a, then we have just u plus 1 here. Now let's take this minus 1 power right here and split it up. So for u to the a minus 1, I can bring that out as like a 1 over u, or like u in the denominator. That way we can just cancel this here. And then with what's left, we could do partial fractions, but let's kind of do it on the fly. I tend to usually avoid the partial fraction. So for 1, I can rewrite it as u plus 1 minus u. That's still 1, but it's going to help us get this cancellation, because then we can break it on the minus sign, breaking it into two integrals. So we're going to have an a out front on both of them. So we're going to have u plus 1 over this stuff. And then for the second one, distribute minus sign to the a. So we have minus a. And now this, what's left is going to be u over u times, I just reordered it, u times u plus 1 du. Cancel, 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 cancel. We just have 1's in the numerator, 2 easy integrals. So I integrate it, let me just factor this a out in front. I don't know why. I guess I distributed it in, then I factored it out. I can't make up my mind, so let's just do this. So integrating the first one, 1 over u, that's going to be natural log of u, or sorry, natural log. I'll drop absolute value because we're clearly always positive on our u values. Then minus the next one, same thing, always positive, natural log u plus 1. But now if we plug in infinity into the natural log, we're clearly going to have problems on both these. So we'll use log properties and bring this together and just rewrite it before we evaluate. So we have a, and then with the minus sign, I can write it as natural log u over u plus 1 evaluated from 1 to infinity. Now, when we evaluate this at infinity, this is clearly going to be going to 1 inside the natural log. So this is going to evaluate to a. As a limit, it's going to become a natural log of 1, but we know that's just 0. Then minus, plug in a 1, we have a natural log 1 over 2 now. Think of this like a minus 1, bring it into the exponent here and flip this. And for my final solution on it, we just get a ln 2, and that's it. So it's really a pretty nice formula. I don't know if I remember it. I'm not that good at memorizing formulas, and I don't know how often you come across that. But when you do, it's going to simplify down to something very clean. So like if this was the square root, you would just have natural log of 4. So yeah, not too hard. Really clean solution like this one. So there you have it. Thanks everyone for watching. Have a good day.